Dear students, in this lecture, we will discuss about Benson High Pressure Boiler. We have discussed in our last lecture about the Lamont boiler, and we have seen that there are some difficulties of the formation of attachment of bubbles on the inside surface of the tube. So this problem was solved by the Benson. So this is the Benson high pressure boiler. Now it is having some features. This Benson high pressure boiler, it was in 1922 argued that if the boiler pressure was raised to critical pressure, the critical pressure is 225 bar. So if the boiler pressure is raised to critical pressure, the steam and water have the same density. Because in the Lamont boiler, there is the formation of the bubbles because of the uh, different density of the water and steam. But if the pressure is raised to critical pressure, which is 225 bar, then both are having the same density. During starting, the water is passed through the economizer, evaporator, superheater and back to the feed line via starting valve A. Means water is passed through this section, economizer, evaporator, superheater and through valve A. During starting, the valve B is closed as the steam generation starts. When the steam generation starts, the valve B is closed and it becomes superheated, the valve A closed and the valve E is opened. Actually, there are two valves, valve A and B, and you will understand how we have to use these valves. The maximum working pressure obtained so far from commercial Benson boiler is 500 bar. Means in this boiler, maximum pressure that can be attainable in this boiler is a 500 bar. The steam generating capacity of this Benson boiler is 150 tons per hour. And this boiler is having temperature as high as 650 degree centigrade. So this is the and this is subject to the metallurgical condition in the boiler. Now this is the schematic diagram for this boiler. So we will see similar to the Lamont boiler, here we are having a blower and the cold air passes through this blower and then it passes through this section which is called as the air preheater. And from this side, hot flue gases are moving upward and passing through this air preheater section. So air which is passing inside the air preheater section will be get heated or warm, and this warm air is supplied to the combustion chamber to increase the combustion efficiency. And after passing the hot gases from this air preheater, it goes out or exhausted to the surrounding or the atmosphere. Now here there is a feed pump and this feed pump sucks or takes water in, and then this water passes through this economizer section here. So water is passing to this section, economizer section, and again as we are seeing that hot gases are moving upward. So the hot gases will give heat to the water passing through this section. Now, then this water after getting heat in the economizer section will move and follow this passage, and this will pass through this section which is called as the radiant evaporator. Because in this evaporator, the heat is taken in from the combustion chamber in the form of radiation mode of the heat transfer, in which the heat is transferred from one region to another region in the form of electromagnetic waves. So the water will pass through this radiant evaporator section following this passage, because we are having this type of waviness of these tubes to increase the heat transfer surface area. And here the water will get evaporated and it will form the steam or the vapor. Then this vapor will pass through the convective evaporator here. This is the convective evaporator. It means in this evaporator, the heat transfer occurs in the mode of convection. And in the convection, it needs the one fluid and one surface. So what happens here? The hot gases will give heat to the outside surface of the tubes of the pipes, which are made of the metal, and inside the pipe or the tube there is the water. So water will get heat from the hot pipe and will get evaporated. So radiant evaporator, including this convect evaporator, both will completely convert water into steam, and then this steam will now go to this section which is called as a superheater section. This superheater section is just closer to the combustion chamber here. So the hot gases which will pass through this superheater section are at very high temperature. So this dry steam will be superheated here in the superheater section, and then this superheated steam will be ready for the application wherever it is required, maybe any prime mover or for the steam turbine. Now there are two valves, the valve B as well as valve A. So valve A is first opened during the starting period. Then after that, actually it is called like the starting valve. Then after that, when the steam is produced, we open the valve B, and through the valve B, we pass the steam to the application where it is required. So this is the functioning or working of the high pressure Benson boiler. Now here we can see there is no storage drum is used. It is a burst through boiler. Feed water will enter here with the help of the feed pump here, and this feed water will pass through different sections, and finally from this valve B we are getting the superheated steam. So the water is entering the boiler and steam is leaving out the boiler. There is no storage of the water or the steam is here. So it is the one through boiler, but high pressure is maintained here. So this is the also called as a supercritical boiler. Now there are some advantages of this boiler in comparison to the Mont boiler. So we can see here in this boiler, as there are no drum is used, the total weight of Benson boiler is 20% less than the other boilers. So because of the elimination of the water storage drum or the boiler drum, 20% of the weight is reduced here in this case of the boiler. Second one, the transfer of Benson's part is easy because the construction of the boiler drum is bulky. It is voluminous, because of which it requires the assembly with the other components, but because there is no drum, so no drum is there, so parts to carry the parts very easy, as well as the majority of the parts are carried to the site without pre-assembly. Majority of the parts can be taken to the site where it is to be assembled very easily. The erection of boiler is easier and quicker. When we have to inspect the boiler or when we to test the different component overhauling purpose, it is easier because all the parts are welded at sides. So, but when we assemble the different parts, it is also becomes easier. The furnace walls of the boiler can be more efficiently protected by using smaller diameter and closed pitch tubes. It means the furnace walls of the boiler can be more efficiently protected by using smaller diameter tubes. We can use the smaller diameter tubes because the tubes are passing through the different section and having the larger area. The smaller diameter tubes can be used here. The superheater in the Benson boiler is an integral part of the forced circulation system. Here we use the forced circulation because we force the water at the high pressure. So it is the integral part of the forced circulation, and no special starting arrangement of superheater heater is required. We do not use any separate arrangement. As we have seen here, after passing through this convective operator, the steam will directly pass to this superheater section. There is no separate valve is being used here. No restarting system is being used here. This is the additional advantage of this boiler. The Benson boiler can be started very quickly because of welded joints. In this boiler, we use the welded joints, so it is having the easiness, or it can be very quickly started. So these are the advantage of the Benson boiler, and it has eliminated the problem of formation of bubbles on the inside surface in case of the Lamont boiler. Thank you.